So I was to say good morning, afternoon, evening to everyone out there, depending on what time of day you're watching this. We're excited to be a part of this virtual vIITSEC 2020. This is the first time that this tutorial has been presented. My name is Brent Smith. I'm the Research Development and Engineering Principal at the Advanced Distributed Learning Initiative. We are a small organization positioned underneath the Office of Secretary of Defense, the Undersecretary for Personnel and Readiness. Jerry?
Yeah, hi, my name is Jerry Gordon. I am currently the Deputy Director for Product Development for Unmanned Systems at Gibbs & Cox, a naval architecture firm. But I was recently, until recently, the Chief Architect for the Total Learning Architecture, which was a culmination of several years research conducted by the Advanced Distributed Learning Initiative in looking at ways of building a true ecosystem of learning technologies and learning data.
Yeah, so in today's tutorial, we want to talk through a number of different things. We have been, I guess over the last 3 years, we've been working with the IEEE Learning Technology Standards Committee to develop a number of different commercial standards. We've run a number of working groups with a host of different DoD stakeholders, industry partners, and academic partners. And over the last 3 years, we've kind of consolidated a four-pillared data strategy that kind of encapsulates this concept of a total learning architecture. So today, we kind of want to talk through this integrated strategy to talk about some of the interdependencies, how things tie together, and things that you all might want to consider as you're working forward to kind of implement a data strategy into your own organizations. A lot of these things are predicated around competencies. Jerry, you want to talk about what we're going to learn about today?
Sure. So we're going to start off with a little discussion about lifelong learning. Some of the definitions really that we've been using, which are words that you've probably all heard, but one of the things that we were trying to do was kind of arrange them into a structure. And this is actually going to be ensconced in one of those IEEE standards, the 1484.1, or the conceptual model for advanced learning technology systems, or what we call CMALTS, which is an active working group. Second, we're going to talk a little bit more detail about what it means to be an ecosystem, some of the characteristics and whatnot that are part of that. Then, as Brent alluded, we're going to dive into competency-based learning. This as well is being captured in IEEE standard 1484.20.1, the reusable competency definition objects. Then we're going to get into activity and resource metadata. This is actually going to be part of a new standard, the IEEE 2881 learning object metadata. Learning activity tracking, which in our TLA structure uses the Experience Application Program Interface, or XAPI, which is also an IEEE standard, 9274. And then lastly, how we capture the summative conclusions of all this learning data in terms of permanent discoverable learning records, which is also an IEEE standard 1484.2, the integrated learning record. At the end of this, the learner should be able to describe the elements of an integrated data strategy for any new or existing programs of instruction. The learner should be able to use a competency framework to define knowledge, skills, abilities, and other characteristics required to perform a specific job. The learner will be able to describe learning experiences, content, activity, resources, and educational alignment to a competency framework using metadata and paradata. For given a series of example learning events, learners will be able to decompose each event and its components of well-formed XAPI statements. And lastly, the learner will be able to explain the relationship between the learning data elements, the components of the future learning ecosystem, and the learning events conducted using those.
Yeah, I would point out that there's a lot of the research and the foundational research that went into these different data standards and whatnot are located on the ADL website. That's at www.adlnet.gov. Under resources, you'll find a 2019 Total Learning Architecture report where we evaluate the numerous different standards and specifications that are available out there and talk about how they all harmonize and align with each other, resulting in this TLA.
Okay, so first we're going to talk a little bit about lifelong learning. There's a recognition that learning is a continuous activity that happens in a number of different ways throughout a person's life or career. And rather than thinking of it as formalized school events that are pierced by other things, we wanted to start thinking about how do we capture this continuous nature of learning at different levels so that we can get a more clear picture of what somebody's actually capable of doing. So one of the standards that we are aligning and harmonizing with in the CMALT's work is called the CEDS, or the Common Educational Data Standard, which is a data model for thinking about elements of a learning environment. And at the top it defines this three-ball meta model you see there to the left, which is that you have persons, organizations, and resources that have relationships between them. So one of the things we try to do is take kind of the constellation of terms that is used out there in the education and learning world and see if we could relate them in some way. And one of our early epiphanies sort of was that what we really have is that you're standing in one of those perspectives and looking across at the other things, and based on that you can describe a certain number of aspects of the learning environment. So, for example, standing from the organization's perspective and looking out at the learning environment, you can talk in terms of the roles that people have with the resources. So the classic roles of teacher and student have now kind of expanded into a larger degree where there's a larger trade-off of control and responsibilities, everything from supervisors in the work environment to colleagues or teammates who are more or less co-equal with you, mentors, tutors, facilitators, students, employees. All of these are different people who are actively engaged in different elements of the learning environment. The second thing is learning situations. And this is really a relationship between the learner and their goals and the things that they do to pursue those learning goals. And those are defined as informal, formal, and non-formal. And lastly, the motivational focus is a lot of research has identified. Motivation is an important part of learning and learning retention. So why are you there in the first place? Is it because you just have a milestone in your life or your career? Are you pursuing a credential that opens up opportunities for future possibilities? Are you trying to get an occupational alignment with a job that you're currently doing, but you have some skill gaps? Are you pursuing just a life skill, something that you want to do? Or is it more about cultural alignment, where you're really trying to refine your soft skills so that you can work within an organization? Every one of these things is going to have a different impact on what the learning is going to look like and how the learning is perceived by the learner. Next slide, please. So the next perspective is that of looking forward from the resources. Now, resources is sort of an open term. It really can mean any physical device or data or thing that's available to help you try to present some kind of learning environment. So some of the concepts that we have here, first off, is goal structures. How are you actually thinking about your goals? The classical instructional systems design paradigm uses what we call learning objectives, and those are tiered into a hierarchy of enabling and terminal learning objectives that are then arranged into modules and courses and phases and things like that. But one of the things that we have done a lot of research with is looking at competencies. So competencies is really designed around working to mastery, and it doesn't always give everybody the same curriculum every time. Because people are starting their learning state at different places depending on their past experiences. So what competency does is help to fill the gaps to a standard, but it's based on competency against those things rather than just giving a grade and starting at the beginning and ending at the end, as with a traditional curriculum. The second thing is resource origin. Curation of pre-existing resources is being kind of popular in the training and education world. Since not everybody has the time or the money to go out and remake their own customized training devices. So there's a process to making sure that it's imparting the right things, that it's accurate, that it's useful, that it's developmentally appropriate to the person who's receiving it. So that's one way of doing it. Or you can go to creating ad hoc or for purpose training and more along the lines of the traditional way of doing it. But that resource origin is interesting from understanding the provenance of the training that was delivered, so that when you need to go back and do some analysis of it, you really understand what it is you're looking at. Next is feedback and control, and this accounts for modern technologies like recommenders or intelligent tutoring systems. And the idea is there that the training might be human facilitated, and that human could be a mentor, a teacher, or a colleague, or it can be resource facilitated, where we're actually bringing machine learning or AI or intelligent tutoring, and it's actually the resource itself that does some sort of reinforcement of your learning progress. Next is delivery mode. This is somewhat of a legacy term, but it's still appropriate in this new way of thinking about things, and that is synchronous or asynchronous. Asynchronous is more like a classroom environment where you are still trying to get everybody to do the activities together, and asynchronous is more of a learning at your own pace. And lastly, there's an attribute in a lot of the classical instructional data structures called interactivity, which is a way of accounting for the level of complexity and by extension, the degree that you would expect something to really give you transfer. So for example, in interactive multimedia, there's level 1, which is very passive, just really just kind of paging through almost PowerPoint, to level 4, which is almost like a micro simulation, what they call immersive. One of the things that our research was looking at was trying to expand upon this, instead of using it as a single flat dimension, into what we call cognitive alignment. This is based on some of the research that was actually done in workload analysis by extending the human information processor of Cardmoran and Newell, the work of Chris Wickens and others, with the idea that there's a certain number of cognitive channels that are stressed when you do a task, and that the closer that the modality of your learning environment is to the things you actually have to do in the work site, the more of those things that you're actually completing. So for example, there's a lot of psychomotor skills involved in being a pilot, remembering where the controls are, or how hard to pull them, and kinesthetic sense and things like that. So obviously a level 7 ICAO simulator is going to do a pretty good job at faithfully replicating all those things. And a PowerPoint slide, so not so much. But there are cognitive elements to a lot of those tasks that can be imparted pretty well with just PowerPoint. So we want to be able to make sure that as we're capturing evidence that you've done things, that we capture the evidence about the thing that's specific to the thing that you've done. So yes, we've checked off the cognitive elements. We haven't checked off the psychomotor elements by showing you this PowerPoint slide. So we can expect that your retention and transfer is at some degree less than if I put you in a real airplane or in front of that level 7 simulator. Next, please. And lastly, the last perspective here is the learner or person view. So this is from the person's perspective, looking at their own training environment, which in that training environment composed of its organization and resources. So first off is learning feedback and regulation. Is the learning externally regulated or self-regulated? The classical classroom environment is very externally regulated. The teacher's doing your grading your homework and checking your assignments and determining whether or not you are participating in class and things like that. Whereas self-regulated has grown out of the adult learning world, where you're actually doing the your own assessments of your own progress. Next is goal and achievement management. Are those goals self-directed or externally directed? This is very similar to the differences between formal, non-formal, and informal training. But again, this is coming at it from the learner's perspective. So are they being told what to do, or are they figuring out what they need to do on their own? Again, this comes from some of the advancements in adult learning that's evolved from the concept of andragogy, which was first fielded in the early 90s, to a different concept you may hear around the ADL called hudagogy, which includes all these different aspects of modern learning theory, to include all the different ways in which you may personally be taking control of your own learning. Next is social reinforcement versus behavioral reinforcement. This takes advantage of social learning theory versus the classic B.F. Skinner or Pavlov's dog operant conditioning. So the idea is, are you reinforcing your learning via the environment and it's monitoring your behavior, or is it more of a collective sort of crowdsourced thing between you and peers and colleagues? And lastly is a concept that we introduced into the data structures and the technology in our TLA research, which we call learner state. The idea is that at any given time, any particular learner has a structure of goals, tasks assigned to satisfy those goals, and then events that are actually recorded when they execute those tasks that will have some kind of evidentiary residue that contributes to determining whether or not those goals have been met or not. And the idea is that you may have multiple of these things in multiple layers that are valid at any given time, and you're constantly working on these things. So we can use this to sort of define a roadmap of where the learner actually is in their learning path. Next. So in addition to those multiple, what we call threads of learning, along a learner pathway, there are actually several different levels of learning planning that may be occurring at the same time. And we've formalized this in a concept we call control loops. This does come from modern control theory. It's also useful for thinking about how intelligent tutors and recommenders work within the environment. So it helps sort of formalize that in the overall ecosystem. But the idea is that first, in your first control loop is really, how do I finish this module, optimizing my current activity? This is where the real fine-grained data is being generated from the learning experience. The second one is, I'm in this class because I want to get a credential or some kind of certification that I can do something. So that class has to be taken in concert with all the other requirements for that credential and optimized. So what I'm really trying to do is optimize my progress towards a credential, learning the things in the most efficient way such that I can achieve that credential and move on to the next phase of my career as efficiently as possible. Third is optimizing credentials to a current job. It's entirely possible that there may be multiple requirements for a particular job. I was an officer in the U.S. Navy, a surface warfare officer. And in my first job, I think I counted up, I have about 22 different jobs that I was required to do or qualify for in the 2-year period that I was stationed on my first ship. And those were all basically being done simultaneously. So the question was, what's the most efficient way for me to put all the checks in the box, given the things and the events that were available to me to accomplish that? The next one is optimizing your overall career trajectory. Going back to that example, on my first ship, my job was to earn my surface warfare officer SWOPIN qualification. That changed my designator in my personnel system from 1160 to 1110. And it was the first essential step on my potential military career of being a surface warfare officer. And then lastly is Control Loop 5, where there are new career goals. So sometime a number of years after that first ship, I decided to transition out of the Navy and get into the civilian world. So there was the question of, how do I recapitalize on the experiences that I gained and apply them best to the jobs that I was pursuing in the civilian world? Similarly, in the military, you may reclassify, gain a new NEC, decide to go do a different career, change branches. That's certainly happening now with the Air Force moving a whole bunch of people over to Space Force. So that fifth control loop represents those new career goals and the new path planning that comes from that. Next slide, please. So with the DoD having defined a fairly concrete pathway for all of its members, it's possible in the DoD to kind of define an overarching vector map of lifelong learning. And this provides us some useful analytic tools. So we define a couple of different concepts here that can sort of help us bucket the information that we're collecting about the learning environment. And that allows us to do different kinds of analyses by using these buckets as sort of advanced filters in the kind of the big data sense. So first off, we have different decision points from accession and selection and initial training that then sends us on a career. And that career is going to be composed of a number of different credentials and jobs and duties and things that we need to go learn how to go do. The speed at which we accomplish those things and the direction for an overarching career arc provides a velocity, and that trajectory then it can be thought of as composed of those goals that are then broken down into tasks that are broken down into specific things that are achieving those events that are satisfying those tasks. And again, that's sort of those three control loops. At different points in our career, we may be able to make selections or screening for different job opportunities that will open up things that were on our path but closed to us until we achieve a certain point. Like for example, you have to qualify engineering officer watch and surface warfare officer in order to be able to select for, to screen for department head school, which is a key milestone in a surface warfare officer's career path. Or at, say, the 05 level, you might select for joint professional military education. That opens up additional opportunities for jobs that you could do that you're not otherwise open to you. And then at some point, you may transfer out, become a civilian, go to the reserve component, or just decide to do something else. So you can kind of see there the five control loops, feedback circuits labeled on this diagram. Next. So next we're going to talk a little bit about federations, about ecosystems. Ecosystem has become a little bit of a brand. There are a lot of vendors and whatnot out there talking about ecosystems, and it sort of exists along a continuum. With the total learning architecture research, we were trying to really sort of open the aperture to a truly complex adaptive system of truly decentralized, decoupled systems that could come together into ad hoc creations and then change their form and over the course of their life, and more importantly, over the course of a career arc of all the members of the Department of Defense. So the first concept that we define is an enclave, which means exactly the same sense that it does in the cybersecurity world, in that it is a defined boundary of computational assets and data that is maintained or owned by a specific organization, and it is used for the subsets of data elements that they own. For example, if you're a rating manager in the Navy and you own the competency data associated with being a bosun's mate, then your facility is going to own that data, as well as the back-end servers that we have defined as the minimum set necessary to participate in this ecosystem. You don't have to buy them from any particular place, but they have to comply with certain interface and data standards. And we separate those up into core data, core services, back-end services, which are kind of like the user directories and file services and things like that you normally think of being provided by like Amazon Web Services. And then lastly, learning record providers, which are any of the devices or training or anything like that that's been instrumented in order to conduct learning. Now, the first step in being an ecosystem is to open it up so that those learning record providers don't all have to be part of a walled garden. You can go to websites as long as you have the way of capturing relevant information off of them. Like, say, go to a YouTube site and go watch a video, and we can capture that you've started and stopped the YouTube video and store that data, even though we're not locally hosting that particular piece of video. Similarly, some of those devices and simulators may, especially for things like bring your own device, those may be very portable and move from one location to another. So as long as we have a way of discovering and controlling for them while they're owned by this enclave, they can participate in the ecosystem and then move on to a different ecosystem. And there could be as many an arbitrary large number of other enclaves or other micro ecosystems that are all connected together in this ad hoc way, where we basically establish a data interface standard and an authority to connect between one group and another for a very specific purpose. There is, however, some enterprise assets, some things that need to be defined at the DoD level that help all this work, and kind of in the same way that the domain name service servers are maintained kind of in the back end of the internet where no one can see it. They farm some of their data down, but ultimately there's a single place where you can say, if I want to go see www.this.com, where is that physically? And there has to be a mechanism to go find that, and that's what these enterprise assets are. And those include what we call schema servers, which we'll talk a little bit about later, directory services, which is very similar to DNS, as well as conformance and data governance that's executed through electronic policy or e-policy. Together, the rules and governance and standards form what we call the ecology. So the ecology is the documentation of the ecosystem. The ecosystem is the physical implementation of this constellation of data and computational assets that are all connected together and exchanging information via those data standards and those ATCs. Next, please. So Brent had alluded in the beginning to our 4-pillar data strategy, and the idea here is that we wanted to not over-normalize the kind of information that represents a learning event. So what we basically settled out on these 4 pillars as being more or less independent from each other. So kind of going clockwise from the upper left, activity and resource metadata describes all of the learning things that you can do, and provides enough attributes about those things in order to be able to, 1, select that one may be more preferable over another, and then 2, to when they are being evaluated as evidence of competency, how do I determine how good that particular piece of learning was in the overarching scheme of things. The other thing that it can contain is so it will contain alignment to design and development activities. It can also store evaluated paradata. So as we start to capture things about the events, under what circumstances were they done? Who was the staff that was running this? What was the simulator scenario that was run? Were there any faults introduced? Was it raining? Did the students enjoy it? Did they do well on their test afterwards? All that kind of information can be used and collected as paradata that can then go back to help reinforce the kind of things that we capture about that particular element to make the overarching control of our training better over time. Next, on the upper right-hand corner there is learning event tracking. Again, this is using the Experience API. The API is controlled through the use of profiles. We have defined what we call a core profile, which will be its own IEEE standard 9274.3.1, or the master object model. And a little bit more about that later, but that is sort of the way of normalizing all the information coming from different devices so that it can be exchanged across the entire ecosystem. Next is the Competency Framework. This includes more traditional knowledge, skills, and abilities, but also other attributes like soft skills, motivations, physical conditioning kind of things. Anything that's really fully describes what is necessary to be capable and efficient at doing a job within an organization. It does include conditions and standards in the same way that learning objectives did, but it's a little bit more complex in the way that those are defined because we now account for multiple levels of mastery. And those competencies are, of course, lined into sequences of jobs and duties because the focus in competency is less the schoolhouse and more on the actual job environment. Lastly is the learner records. And again, the learner records are the summative conclusion of evidence that was collected and processed. So the evidence is in the form of that learning event tracking. The processing is based on comparing the actual performance collected against a rubric, and then evaluating that formative information against activity resource data and the competencies that that activity was designed to support. So that summative thing then becomes you are now competent in, or you have been recommended and conferred for a credential of. Those learner records are highly distributed. We'll talk a little bit more about that with some interesting research that's occurred over the last year. And there is another number of other papers here that are being presented at vIITSEC about that as well, and I'm on one of them. That's why I'm throwing my own hook in there. But the idea is that that becomes the snapshot of a person's capabilities to function in the job at any given time. Next. So next, a little bit about those enterprise assets and data governance. As you can see, the data governance ecosystem is complex in and of itself. There's a number of different standards, a number of different data structures, a number of different federated or distributed data stores that are necessary to make this all work. So the blue box there in the middle is, again, going back to that core data, core services, and back end of any particular enclave. And then those different elements have to interface with different governance elements. And there are adjacent segments that provide governance as well. For example, there is governance related to interoperability of systems. There is governance related to the manpower and personnel policy. There's governance associated with the use of machine learning and artificial intelligence. There are specifications for manuals that are used to maintain concurrency of with deployed systems. There is governance associated with reporting out the readiness, or the personnel component of readiness. And ultimately for the DoD, the idea is the reason for doing all of this is so that we can start to make some reliable predictions about readiness. And then lastly, of course, is cybersecurity, which is a big part of protecting those data and assets, computational assets, as well as being able to enable that bring your own device. So there's significant compliance with the risk management framework as well. Next, please. So going back to those enterprise assets, there are a number of things that every organization may need to leverage. And using what we call the semantic language of the web, point to in an electronic format. Kind of the secret sauce or linchpin between these two is the Schema Manager, which is that there has to be a place that is the authoritative source of what something is called. Some of the big technology firms like Google maintain a thing already online called schema.org. You can go look it up. And there's a lot of things that are already defined in schema.org. Challenge, of course, is that it's sort of open. So there's opportunities for hacking or malfeasance. So one of the, for the DoD in particular, one of the things that we're looking at recommending is the creation of a schema.mil, which replicates all that same behavior, but just behind the military firewall. Then there are local learner profiles, local experience indices, local asset repositories, and all of that needs to be joined together by some kind of directory system that tells you how to go find all of that data, as well as helps you reconcile what things are called back to that authoritative schema source. All right, lastly, I'm going to talk about competency-based learning, and then we'll turn this over to Brent for a while. But again, we talked a little bit about that shift to competency-based learning. The real big reason for this is that it focuses on the job context and the applicability of what you're learning to actually doing the job in the job site, as opposed to optimizing your ability to get through school and pass the course. The second thing about it is that it focuses on filling gaps rather than completing a prescribed course of instruction. The opportunity there is for what we call learning compression, in that if you already know how to do 30% of what you're going to learn, you don't have to do that 30% again, which means that you can get out of your training environment and back into doing your job more quickly. It's also based on evidence instead of just assessment. The difference is that assessments can be evidence, but evidence opens itself up to a wider world of validation of ability, to include all kinds of things like anything from doing the job for real to observations of on-the-job training. And competencies are complementary to credentials, but they are not the same thing. And in particular, credentials are based on trust, and the trust is in the trusted officials who sign off on the credential, who are provided the information that comes from the evidence of competency in order to be able to make their decisions. But the interesting thing about this is that the system that we evolved in our research allows auditing of that over time, so that if you start to see some downstream performance problems, you can go back and look to see what it was that the credential was actually based on, and exactly how that evidence was collected, to determine if maybe there are other things that are part of that job that we didn't put in that qualification standard, and we need to. Right now, those analyses are done on a kind of a 5-year basis, and it's sort of an ad hoc process based on subject matter experts, and it's been powerful. But it does mean that between the 3 years that it takes to update a curriculum and the 5 years it takes to update a credential, that we might have an 8-year gap between something really changing out in operations and are actually being able to go back and make sure that our trainings pipeline has accounted for it. And there's opportunities for things to go off the rails that way. So the idea is that with this research is that we can tighten that cycle down quite a bit by managing the data relationships.
Yeah, I would point out, Jerry, that there's the Credential engine, which is a commercial capability that kind of takes a lot of the different credentials that are out there and decomposes them into the competencies that they represent, and they use that credential transparency description language to do that CTDL. That kind of plays into how those they get structured and then fed up to, but that also kind of creates the ability now to align competency definitions. It's kind of the baseline between the training and education community and then the operational, the different functional communities. If we look at a competency as you said earlier, the knowledge, skills, abilities, and other attributes that you need to do to perform your job at proficiency, I think that's a good tie back.
Excellent point. Thank you, Brent. Let's say next slide, please. So we talked a little bit about the 1484.20, which is the reusable competency definition object. One of the key findings in our research was that we needed this to move away from traditional hierarchies to what's called a directed acyclic graph. What this does is it allows us to preserve additional context in the relationship between things. So not just that something is a child of a parent, but why is it been used as a child here. The other thing, of course, it does is it allows for multiple parents or multiple inheritance, which allows for additional complexity as things change. The strengths of those various relationships might change, and allows you to have a better understanding of why something might move around or not be done in the same order every time. So more importantly, it allows these to evolve over time and allows us to maintain the configuration of how those things changed. So we can actually see the impact of how learning for a population of folks will change based on what version of the competencies they were actually trained against and how those competencies evolved over time. Next slide, please. Okay, so it is probably a good time to point out that there are some taxonomical challenges in defining competency. If you get 10 educators in a room and ask them what competency means, you'll get 12 answers. So some of the things that need to be addressed by the community as we start to formalize the standard. What are the discriminators between what a generic person might be able to do and a specific person can do? And do we call this a competency object, a competency definition? Doesn't seem like there's much of a consensus in the literature, which tends to conflate the two under the overall umbrella of competency. Does a competency refer to any constituent KSAO? And does A stand for ability, attitude, aptitude, or some combination thereof? Is attitude just a superclass of other behavior? Is there a taxonomy of other behaviors? Is there a discriminator between the base level defined in a KSAR competency object and any kind of higher level? So thinking about how those are all structured from a data perspective is going to provide transparency for between different competency frameworks that can then aid in their reuse and, more importantly, their interpretation later when you're trying to determine whether or not somebody who has that competency is going to be a good fit for a job that you need them to do. And then lastly, is there a syntactic standard for expressing competencies analogous to the task conditions and standards that are defined for learning objectives? If so, what is it? If not, should there be? It does not appear from a lot of the literature right now that there's really any consensus on that as well.
Yeah, the ADL initiative's done a lot of work over the past few months with Army, Air Force, Defense Acquisition University on competency-based learning. And there's a big challenge in how do we define global competencies, such as marksmanship, and then localize the context, like you'd mentioned, the task conditions and standards and whatnot. But part of the data strategy needs to be what are those global attributes and how do we normalize those? And then having the resources and infrastructure to be able to do the alignment between the local context and that global standard so that you can see, okay, here's my global marksmanship competencies, but special operators need to have these additional capabilities or these additional skills. And then understanding and being able to quantify those deltas.
Thank you, Brent. Next. So you heard us mention before the factory learning model. This is kind of the classical John Dewey public education system that's served us pretty well through the 20th century. And for those of you who have an instructional systems design background, you're probably familiar with the ADDIE model, which is analysis, design, development, implementation, and evaluation. And this is kind of the overarching way of thinking about building out curriculum. And of course, in that environment, the selection of goals, the selection of tasks, the structure of the curriculum, the presentation of the curriculum, that's all managed for you by the organization. And then you are, as the learner, are the recipient of things. And it's done in the same order every time. And the way that we build these for the military is we start with a job duty task analysis that talks about the knowledge, skills, abilities, and behaviors that you need to do a job. And we break these down into what we call training tasks, which are then combined with conditions and standards to create learning objectives. Those learning objectives are arranged into a linear curriculum that may or may not include a lab practical. It's presented at a schoolhouse, and then we do cohort tracking, and if you get your 80% by the end, then it results in a credential. This is the factory model. This particular slide is color-coded here, where the stuff that's in black is actually common to both the factory model and the emergent competency-based model. But the red stuff is the stuff that is now de-emphasized or will be a change in between them. Next slide, please. So what the competency-based model looks like is, this is the little infinity symbol there is to show that this is more of a continuous process, is that we have, instead of a linear curriculum of things that we want to teach you, we have a network of job requirements, and that network may change over time as the job changes. It's composed of those job duty tasks, standards, knowledge, abilities, skills, and behaviors, but it also includes elements of the level of mastery to show that at one level, you're expected to be able to do this to this degree, but at a different level, you're expected to do it at a different degree. So, for example, the marksmanship. So, for your basic marksmanship, basic rifle marksmanship, you need to be able to hit. I think the minimum is like 180 points to qualify. 300 targets. 30 targets from 25 to 300 yards, and you got to do that a couple times a year. Don't quote me on that. I may be misremembering some of the numbers. It's been a couple of years now. But for a sniper, that's that's not going to be good enough. And so their basic entry point is, I believe it's 240 on that 300-point scale. But they have a whole bunch of other things that they need to learn that your basic marksmanship doesn't learn. So their marksmanship competency is necessarily going to be a lot higher than somebody who's a basic infantryman. Similarly, instead of just doing assessments and comparing grades, we are collecting evidence of competency because we're trying to drive towards mastery. That can include that same trust and verification of instructors and empowered individuals, schoolhouse tests and lab practicals, but it can also include supervisor evaluations, on-the-job experience, and the inclusion of what we call ubiquitous learning, which is things that you can do on your mobile phone or on YouTube or online, all those other things that you can now do to help bolster your learning and improve your competency, which was just sort of done in the background in the past, but now we're actually going to be able to help students optimize learning experience by capturing that kind of data. And what that does is, at that higher level, is that it gives us an audit trail, and it allows us to make more interesting inferences about the capabilities of our populations and subpopulations, as well as inferences about the best way an individual learns, so that we can provide recommendations to improve their learning and thus improve their efficiency or decrease the amount of time that it takes to train them in the future. Next slide, please. So we talked a little bit about the chain of evidence and trust. So and this is sort of the operational view of what we have built into the TLE research as what we call the federated LRS or learning record store structure. So the idea is that in our learning events tracking, which is talking about where the learner has been, we start with noisy event data, and this can be in any standard. It exists usually within the actual training device. And that training device may be interested in everything down to every mouse click or point or whatever. But that information doesn't necessarily need to scale up all the way. So it will have a boundary between that edge noisy device and our core systems that we talked about, those core computational systems and data. And that is stored as transactional event data. And that is normalized against the master object model that we'll talk a little bit more about later. That shows that sequence of learning pathway and learning threads of exactly how you did whatever it was you did. A key point here, though, is the rubric is actually pushed out to the noisy event data so that the procuring agency or controlling agency controls the definition of right. But once they've decided that somebody has done something correctly, then what the thing they did and under what circumstances is then normalized to that transactional event data. That transactional event data can be processed by a competency tracking system such as the Competency and Skill System, or CAS, which is actually the engine underlying the Credential engine that Brent talked about before. And it is similarly normalized using that MOM profile to authoritative event data. And the authoritative event data is the digital signature that you have done something. So this becomes the beginning of the trust chain. So the transactional event data is your evidentiary chain. The authoritative event data is the beginning of the trust chain. The trust chain then updates your local learner profile and exposes that to the greater world in what we call a enterprise learning record repository, which is a way of finding all the different local records that you were issued a competency or a credential. And there's a whole host of things that are necessary on the back end to make all that work. You can kind of see that there in the yellow boxes. But the real point of this is that we start from that very noisy data, we clean it up, we keep an evidentiary chain that is auditable, and then we summarize that into a digital signature that then supports the issuance of a competency and credential. But it is all linked and it is all auditable and it is all discoverable. Next slide, please. So this brings us to our first exercise. We thought it might be useful to kind of brainstorm competencies, especially to see what the audience thinks that competency is composed of. So maybe we can start addressing here as a group some of those questions about taxonomy challenges that we talked about before. So, for example, what are some examples of competencies that you might see in your organization? What are the kinds of things that, leadership skills, behaviors, technical proficiency, team skills, anything like that that is necessary for you to be able to function within your organization?
Yeah, and working with the Air Force a while back, they have their competencies directorate, and I think we actually have some webinars posted up on the ADLNet website that talks about how they're looking at institutional competencies and then some career competencies. We're working with Defense Acquisition University. They have their own career field competencies. We're working with one on contracting specifically right now and trying to align all their different training and education resources to that career field competency. So it's really at what level do we try to guide people to create those, right? It can be really any level.
So the next part about competencies is some of those soft skills and other behaviors. If at all in the human resources world, you've heard an awful lot of emphasis on soft skills in recent years, or cultural fit, as they talked about it in the hiring world. The idea there is that what are those things necessary for you to be able to function within your organization and team? Do you need to be an abstract thinker? Do you need to have confidence? Do you need to have empathy? Are you detail-oriented or big picture-oriented? Are you organized or are you hyper-performing? How do you communicate? Those kind of things. All of which might be things that will enable success in one organization that might not be as successful in a different organization.
Yeah, so what do you think the alignment is between when you talk about ELOs and TLOs and competencies? I know we've had conversations in the past about, is a TLO a competency? Is it the same thing? What are your thoughts?
I think that ELOs and TLOs are fodder for competencies. Particularly the knowledge elements are sometimes artificial because of the nature of the classroom. The way I put it is that ELOs and TLOs are the list of competencies to succeed in school. They're related to the competencies that are required to succeed in the job, but they're not the same.
That's good. Yeah.
So, and unfortunately, I don't know that there's a hard and fast way of determining which ones are which. It just requires some sort of reverse engineering to figure out which ones are applicable to move over to credentials, to competencies.
Yeah, that then becomes kind of the challenge in migrating from the traditional structures over to a competency-based learning model. Migrating all the courses and activities and content that you already have kind of set up in that ELO TLO structure. So maybe there's a way to think about it in the context of baby steps, right? Certainly a competency won't consist solely of ELOs and TLOs. It'll include a lot of other attributes and other elements, but that might be, in some elements, some aspects, a decent framework to at least start with.
I agree. Got to start somewhere, and we already have the ELOs and TLOs.
Yeah. So evidence, that's a tough one, right? You talked about being able to collect evidence from the workplace, from other systems outside of training and education activities.
Yeah, so I think the big takeaway here is that we need to start treating all learning at certain level on a level playing field. So it's not you go to school and then, oh yeah, you do the simulator, but we don't really record anything about it. Or yeah, you go to school, but then you have a job, and they're two different things. So what we're recognizing is that the wall between manpower, personnel, and training is somewhat artificial. And that we really need to think about that the personnel aspects as well as the training aspects on a level playing field. And a lot of the research that we were doing was trying to come up with data structures that enabled that.
Yeah, I think one of my big takeaways from this is also the longitudinal, I guess the lineage between what's being taught, the competencies that are being taught, and then the outcomes in the operational community. So those KPIs that we can start to trace back to start to look at impact. Did this training work? Is this training enough? Where are we missing the ball?
Right. And we didn't talk about it before, but for those in the audience that are familiar with the Kirkpatrick scale, Kirkpatrick level 4 is when you determine whether or not the training that you gave is actually having positive behavioral impacts as people are moving out to their jobs in the fleet or whatever. And we almost never do them. Usually it's after something explodes or a lot of people are killed, and they're usually very expensive analyses. And one of the hopes with this research is that we can start to do some of that more empirically via the data that we're collecting and auditing with our data structure, or with our data strategy rather.
Yeah, so as you all in the audience go through and think about some of these examples, if there's any of these that you want to talk about, or if you kind of have some ideas that you want to bounce off of, Jerry's my contact information are at the end of the tutorial here, and we're happy to take emails and whatnot to talk about what you all came up with and run them off of some of the different standards and how you might quantify that.
All right, last slide for me, and then I'll turn it over to Brent. So Brent alluded to the Credential Transparency Definition Language, or CTDL, before. This is a standard. There are a number of other ones that are emerging in the industry, such as Open Badge, that effectively has a way of digitally preserving that you have been awarded a competency or credential, and it's not just a list of things that can be exchanged between systems, but it actually preserves enough uniqueness in encryption keys in order to be able to be non-repudiable, such that if you're carrying around one of these things, someone can go and determine that it's valid. Kind of like the gold stamp badge that you get on a certificate from any military course you've ever taken. This is sort of the digital equivalent of that. So it has several components to it that need to be preserved in data, and that's part of the purpose of the authoritative databases, to store the meat of that private encryption key that goes to this badge. Again, with that, I'll turn this over to Brent for the second half.
Yeah, before I turn to the slide, I would point out that you're going to see experience again very shortly, but I would just take note of the definition that we have there. It's a 3-tuple of content plus activity and educational alignment. All right. So when we talk about metadata for all your different training and education assets, a lot of the work that we've been doing is informed by a project we have called the Enterprise Course Catalog, and that's part of an enterprise digital learning modernization initiative that the ADL initiative has been tasked with. And in doing this, we've kind of been working with the IEEE to build out a draft standard for what a modern learning activity metadata standard would look like. And so we've certainly looked at things like Learning Resource Metadata Initiative. We've gone through a lot of the different standards organization, like SEDS and the Post-Secondary Education Council standards. Credential Engine has a learning opportunity metadata. And so we kind of created a spreadsheet to encapsulate a draft standard. It's largely based off of the learning object metadata, which was part of the old SCORM standard. And that broke it down into 10 classifications. And then there were different data elements under each classification. So in looking at how those things are structured, we thought, well, that's not really representative of how training and education needs to roll up. It doesn't give us the granularity that we're looking for. You might have a piece of video content that's used in an online learning course, it's used in a classroom course, or it's used in a mobile application. It's used in a number of different activities. So we wanted to kind of break it down and be able to increase granularity. One of the other challenges that we had with LOM is that if you didn't fill out any data elements in LOM, you were compliant. With the advent, with the upcoming future learning ecosystem, we expect that artificial intelligence, machine learning is going to play a big role in recommending content and helping automate scheduling and career trajectories and career field planning. And to be able to do that in a smart and intuitive way, we need a formal way of describing all of the training and education assets that we have at our disposal to use. So, working with Jerry and IEEE and working with a ton of different groups, we've kind of come up with this mindset that we need to work, activity plus content equals an experience. Now, you can have a number of different experiences together and knit those together into kind of an experience set, which in some cases might be a course, and other cases it might be a program of instruction, and so on and so forth. Okay, so to get a little more detail into things that you need to think about, as we roll up learning content into activities, those roll up into experiences. Each experience includes a whole different other set of data, right? So all of these different types, the content, the activity, and the experience, will all have their own type of alignments. Certainly the content and the learning activities will have some sort of cognitive alignment. Typically we try to look at an activity as maybe it's an ebook reader or a simulation platform or a learning management system. And then the learning content would become an ebook or an ebook chapter, maybe a simulation scenario, or it might be some web assets, a video asset, some sort of interactive HTML5 application, something that is, so it's really kind of delineating that. The content could have an alignment to knowledge types. The learning activity is going to certainly have an alignment to different things, maybe some of the competency metadata that's out there. If you have learning activities that are better for fine motor skills or other attributes, that might be more suitable for some of the medical simulations that are going on there. But all of those roll up into experiences and then experience sets. And we'll go through that a little more detail here a little bit. So most of your metadata standards, and this one in particular, does have a number of different metadata classifications, different functional classifications. So we kind of have general information. That's your basic ID, your activity IDs, and other data that's generalized across no matter what type of resource that we're talking about. We include a lot of the life cycle information that's absolutely needed by almost any DoD organization to figure out who's paying for this, who's the owner of the activity or of the course or the content. When it's time to update it, who has to fund that, and where does it have to go? We certainly have a lot of technical information. When you think about when LOM was created many, many moons ago, and what we have now at our disposal, there's a lot more technical requirements. So things that we've done in this instance is really tried to look at, does it make sense to have settings or other installation notes? What are the technical requirements? What type of sensors are used? And trying to look at how do you define metadata for a program like the Army Synthetic Training Environment Program. Those different activities include video sensors, biometric sensors, a whole host of other types of data collectors that are outside of the traditional Experience API, and they may have their own proprietary data formats. So we tried to create a standard that was very extensible, that allows you to set up the different types of sensors or biometric devices, but also that allows you to set up, where is the metadata repository for this asset? Where is the LRS endpoint? What other data types are being collected there? And where are those log stores and those data repositories? All with the thoughts that as you have this information, you can include pointers to where all the data stores are. Now you can create threads down into those data stores as needed, so that if an intelligent tutoring system or some other sort of AI system wants to come in and analyze performance data or analyze a bucket of video data or other biometric data, you can do so down the road. So we're trying to think about how can we create options. And so as you think about how you're going to tag content in your own organization, those are things that you might want to consider. Certainly learning content, that shouldn't be too difficult to do. What what we've kind of done is started cross-referencing with a lot of the content types and the activity types that are already resident on the XAPI vocab server. That will be replaced here in the next few months with the XAPI profile server, but we'll still have a lot of those basic definitions for activity types and content types located on that server. But content, that gets pretty deep when you start thinking about engagement levels and sensory stimulus and the different knowledge types or skill types that's trying to exercise. The semantic density, that's an old LOM field, but that's actually pretty relevant today still. Learning activities, and they roll up into learning experiences. We have to think about instances. Often courses, you'll have the same course in a catalog, but it's instanced many, many different times. And lastly, Jerry touched on this earlier about paradata. We feel strongly that paradata is this derived metadata based on usage statistics are going to be pretty important. And so that's one of the reasons that governance is going to be so critical. As we plant all the seeds of this data, we know that we're going to be able to do a lot more things in the future. And so we have to stay current on the data we're collecting and how that gets propagated back to this concept of an experience index. So a simple example, we took a attribute from schema.org course metadata called aggregate rating. And in looking at where that data resides in different networks, it doesn't sit inside a typical course catalog. Oftentimes, at an organization like Defense Acquisition University, that data is derived out of the course surveys that every student takes after they finish a course. That information and this metadata is going to be held elsewhere as well. As we were building out the draft standard, we kind of reconciled it with Mill Handbook 29612 and all the different design artifacts that are created throughout the course development process. We also cross-reference it with TRADOC Field Manual 350-70 to look at what other data types are they generating in each of those different artifacts. So now as we go forward, we realize that we don't necessarily want to think about having humans required to do this all the time. We want to automate this as much as we can. This is a snapshot from some of the TLA documentation that Jerry and I and the entire RD&E team at the ADL Initiative have built over the past couple of years. It's part of our Div 2, and it really gets into some of the specifics and how the high-level things need to kind of interoperate and roll up together. Do you want to say a few words about that, Jerry? Or
yeah, sure. So a big part of it, and this is one of the residual questions we have, is sort of the attribute affinity. Having done an awful lot of work with data that was created for other programs in the DoD in the 20 years that I've been out of the service, a lot of times where that data is data elements are captured is designed around making it efficient to run on the system when it was first used, as opposed to making it understandable to figure out what to do with it next. So there is, of course, a performance trade-off to having very complex data structures, but we think that to really capture the shareable reuse kind of things that have always been the goals of these initiatives, we're going to have to unnormalize things a little bit.
So next, I think we'll go into this next activity, which is really thinking about your own learning activities and experiences and the different content you might have.
Think about some kind of training exercise that you have at your within your command or in your organization. So what are the kind of things that you have people do in order to be able to be trained? Everything from somebody sits down with you and goes through it, to PowerPoint slides, to online web training, to we're going to send you down to the factory floor and have you observe. So what are the resources required to do that? Why would you do that versus something else? Who or what defines what right means? Why would you say that this activity is a better choice than another activity? What parts of the instructional goals does it not address? And then lastly, and this is again going back to the accurate predictions, what else might contribute to variances in learning outcomes from performing this activity? Because the unspoken part of this whole concept of control theory is that we are trying to reduce the variance in learning outcomes. And part of that is training to mastery. Part of that is optimizing the selected media to the individual so that you're less likely to see them fail.
So learning event tracking. This is what we were talking about with XAPI. So what XAPI eventually came out to end up being is an activity stream. It's a actor, a verb, and a object. So this kind of breaks it down in here. I'm not going to go too deep into this. It's very extensible. There's a lot of different context fields. There's different concepts that it can accommodate. And there's a lot written about XAPI. There are a ton of resources out there, a ton of people out there teaching it, a lot of work groups, community resources to learn as much as you want to know. I know there's dozens and dozens of papers published at previous vIITSECs as well. So when we think about an XAPI statement, though, as we want to start tracking lifelong learning throughout the career at DoD, we know that we need to be able to track the actor. We need to be able to reconcile the actor with the learner. So we've been working with the DoD's CIO office quite a bit to implement their identity, credentialing, and access management policies into our TLA sandbox. And we've been working with them very closely to get approvals and working with the other stakeholders to really nail down that we're going to start using the DoD ID as the actor to anonymize learner data, both in transit and at rest. Up until May, that was your 10-digit EDI-PI number that's commonly accessible on the back of your CAT card. After May, I believe they're changing that over to a 16-digit PIV number, but it's still going to be your DoD ID. That helps us fall in line with not just ICAM, but the federal identity, credentialing, and access management. So now, by aligning with the PIV, you're able to start tracking an individual learner throughout their DoD career. It is limiting. It's not the end-all answer, but it does look at once you go from a uniform, say you retire, now you're a civilian DoD contractor, or you go back into become a defense civilian. That number tracks you throughout your life more than any other type of username or enterprise username. It doesn't change after marriage or any other reason. So that's why that makes a really good attribute to use to track your lifelong learning. All of that is managed through the personnel, the PDR, the personal registry managed by DMDC and accessed by their attribute services. The XAPI statement is an actor, a verb, and an object. And so the verbs, we remember what Jerry talked about with those federated LRS systems. The noisy LRS will collect a number of different verbs. It's going to collect every button push and knob turn. But as we attempt to normalize that data to send it up the chain, up the different echelons, or to make it so that other systems can kind of normalize what that data actually means, we use this master object model. That's really based largely on CMI5. If you're familiar with SCORM, the CMI core is the predecessor of CMI5, and so there's a lot of similarity in the verbs that are used there. And then objects relate to the activity, and one of the things that we need to do in the way we're doing things with XAPI is that the object ID has to correlate to the activity ID for the metadata file that's held in an experience index. And that has ramifications down range, but what that does is that it allows any system to pull in that MOM statement and then pull the metadata about the activity that's generating that MOM statement. So if learning system A or simulator B generates a MOM statement, I can go in and now I can pull in your learner profile. I understand who you are. I know where you are in that life cycle. I know your learner state. You've started it, you've paused it, you've completed it, or you've satisfied it. And then I know which activity it is, so I can pull in all the metadata to understand what that system is and what is it aligned to and all these other attributes about it. Jerry, you want to take this one?
Sure. So again, the master object model is going to be the perspective standard 9274.3.1. The idea is that we wanted to track learning pathways and how the individual intersected with the rest of their learning environment, their organization, other people, and the resources, with the understanding that we didn't want to capture that at a very coarse grain, like curriculum or class or something like that, but actually at the low level that really could give us insight into the different ways in which somebody learned. Because the idea that you might be doing multiple levels and multiple perspectives at the same time. So, for example, you may be enrolled in a course and you're going to the class, and you're a student in a class of 20, and you have an instructor and they're following a curriculum and they're putting stuff up on the overhead. But you might find something interesting and want to go learn more about it, but you're doing that yourself. You're directing your own goals, you're regulating your own learning, you're finding your own resources, you're curating your own lists. You might share that list with somebody else in the class that you know has similar interests to you do. But then you might get to an area of the curriculum where you're not doing so well and you're going to fail. And you go and you put together a study group to try to find ways of improving your ability to pass the next test. And you might pull another mentor into the circle who's somebody or as a tutor, somebody who's good at it. You might go and look up additional videos or read other books or other things like that. So those threads are all woven together into these little micro curriculum that are interleaved within that macro curriculum. And the idea is that if we really want to capture all this information, we have to do it in a way that each of the devices is what's called stateless. It just shows up, exchanges information, and then goes away. And that can happen all the time in relatively free form. There's no one component that's supposedly in charge of making sure this all happens. It's just data responding to messages. So in order to do that, we had to have a way to normalize not only the data that was coming in, but normalize where these devices were coming in within the overarching scheme of things. And that is the purpose of the learner object model. Defines 8 states that for every learning event that you're doing, whether or not it is a 6-month-long course or a 5-second, how do I do this on YouTube, or anything in between, you go through the same sequence of things. Sometimes they're implicit, sometimes they're explicit, but you always go through these things. So there's always goals that are setting. Either the goals are set for you or you're setting them for yourself. There's always some kind of planning activity to figure out how you're going to do this. Either it was part of the curriculum development that the professor did, or you're figuring it out, I'm going to go look up this YouTube video. And then you have to schedule time to go do it. Then you have to launch it. And then while you're launching it, you want to capture information about it. And that's where the CMI5 comes in terms of defining a much tighter learning object model for of initiating and launching and updating results and completing and closing out the specific activity. And then once you have the records associated with that activity, you need to contextualize it within the overall learning experience. Is it something that you were working on? Is it something that you haven't worked on yet? Are you looking ahead of the rest of the class? Are you way behind the rest of the class? Is it just something that's kind of oddball and you were interested in it? Then you have to evaluate the trust of the information that came in. Did a human being who was your teacher sign off on this? Did the device sign off on this? Which device was it? Did you just find it on YouTube? Is it still something that somebody had already approved or curated for this purpose? And then based on that trust, you locate the person now within their overarching learning goals. Is this evidence that they now know how to do this thing that they've been working towards? If yes, then we check it off. If not, well, we'll put it in there, but we're not going to give them 100%. We'll give them something less than that. And those activities always happen all the time. So the idea is that if I take 20 different devices, especially when I start talking about tutors or LMSs or anything like that, they may do different elements of this themselves, and they do it in different ways. As long as they're reporting the steps that they are doing and report them the same way, you know where the person is in the terms of this learning thread. So any steps that aren't done can then be done by going back to the central data where all the information is really stored. So for example, an ITS might be doing goal setting and planning and scheduling and launching and capturing and contextualizing and evaluating its trust and updating the student model and locating the student continuously, and then reporting that information back to the core. But I might give you a PowerPoint slide and leave you on your own, which means I've chosen your goals for you, but you're going to plan how you're going to have to go use this to go learn how to do something. You're going to have to schedule time to go do it, and you're going to have to open it up. You're going to go do it or capture something about it. Then as that information is related back, another process may contextualize that and go, okay, well, he had 4 PowerPoint slides to go through, and he's done 3 of them. He's we've decided that him or her self-checking themselves off on having done this PowerPoint slide is sufficient. Or maybe it's not. Maybe I need to go back to the LMS and actually make sure that you went through all 55 slides, so that it evaluates the trust. And then I locate you accordingly. So, and every other different type of device or experience may be different, but as long as it follows the 8 steps and reports out the information of the steps that it did, the whole system will just kind of work.
Let's move on to the next exercise, which is learning performance measurement. So one of the things about XAPI is I often use the analogy that it's more like data farming than it is like data mining. Using XAPI and XAPI profiles, you're really planting the seeds of data that you want to collect and grow into meaningful information. So in walking through this exercise here, we want to think about how would you instrument your different activities. When you think about a profile, one of the things that's important becomes context. There's a lot of different context fields that you can start to use with XAPI. If you think a profile is kind of like instructions for how are you going to implement XAPI for a particular domain, like marksmanship or tactical combat casualty care, or for particular delivery modalities, like an ebook or maybe a serious game or a learning management system. And so as you go down into the weeds of what data do we want to be able to collect, one of the things the profile does is it keeps the semantic similarities across different types of activities. So a lot of the learner record research that we've been doing lately is based on an other project that the ADL initiative has right now called the Enterprise Learner Record Repository. This is one of the 3 pillars for the Enterprise Digital Learning Modernization Program. It wants to tie to that authoritative identity, your DoD ID, and we'll be looking at other ways to get coalition partners brought in or family members of military and DoD personnel, things along those lines. But for right now, the whole goal is to start tracking lifelong learning within DoD, but also try to get enough community buy-in and adoption so that we can start to transfer this learner data, one, allowing learners insight into their own data, allow them to manage their own data, protection of that data, protection of the personally identifiable information or protected personal information, PPI, and put that all into a format that can be transmitted and communicated back and forth across institutional boundaries, across systems and platforms, any connected system, really to try to get to that future learning system, future learning ecosystem that we were talking about earlier. So certainly there's some things that you would expect to see in any learner record. Credentials, right? The status of different credentials and maybe different courses that you've had. That makes sense. And there's already a lot of standards out there that are available that are doing that. We've done a review of a whole host of different standards organizations that have their own learner record standards. And we've actually leveraged an awful lot of work that's being done by the T3 Innovation Network. You can Google them. They've got a lot of tools. They've got a learning resource hub. They have a mapping tool that has kind of cross-referenced all sorts of different standards that are out there, kind of made our work an awful lot easier to be able to align and harmonize all the different data types that we're trying to put into this integrated learner record that's part of the 1484.2 standards working group. We'll get into that here shortly. So when we talked about credentials earlier in one of the slides that Jerry was showing, he talked about all the different types of things that can go into credentials. I think one of the things that I would like to mention is that based on that T3 mapping tool, they had a number of different classifications. So they broke the learner records down into data types that are about the person. So certainly name, address, other types of information that's fairly standard. The learner record includes person information, organizational data types, information about the organization that is feeding that record. Employment, that's a big part of training and education. What are your previous military history? Where's previous jobs, previous duties, previous deployments, other knowledge, skills, and abilities that have been learned on the job, start dates, end dates, reasons for hires, things along those lines. Not all of this is going to come from training and education, certainly within DoD. And so, as we work through this with the standards community, we have to look and see, okay, well, here's all the open HR standards, here's all the training and education standards, and here's where they cross over so that we can really create a more cohesive talent management pipeline so that we can start to do workforce planning and look in the future and say, well, here's our current workforce skill set, and here's what we need to do in the future. Who's the best group of folks that we can cross-train to meet these needs and requirements in the future? So getting into FICAM and ICAM, that's a big part of what this Enterprise Learner Record Repository is going to be. And the only way that we can really do the lifelong learning is by having that identity ubiquitous across your DoD career. But that also plays with a lot of these other ongoing cyber initiatives here. So multi-factor authentication, that's pretty common for most of the folks in DoD these days, right? But moving to a zero trust architecture is going to be something that's really coming out in the near term. I know in August of 2020, NIST just published their zero trust architecture white paper, and the DoD is expected to follow here by the end of the year with their own reference implementation. And so we'll be continuing to monitor that to see what are the touch points to an overarching data strategy. So that was a lot to swallow in a short amount of time. So I think that the key takeaways are that there are existing data standards out there. The 5 that we talked about today are the CMALTs, the configuration model for learning technology systems, the reusable competency definitions, the 1484.20.1 IEEE standard, the learning activity metadata, IEEE P2881, the experience API, which is IEEE 9274.1, I think, and then the integrated learner record, which is 1484.2.
The future ecosystem is going to require strongly typed data contracts, and that means a minimal set of things that everyone has to agree will be done a certain way, and then agreeing to do them that certain way. A lot of the success of ecosystems is what we call the rule of 3, is where you break things up into, this can be in the Wild West, this has to be done exactly the same way, and on either end, and then the middle is, okay, you get a lot of freedom to define what you're going to do, but you have to do it, the how you're going to do it has to follow a standard. Well, the idea that it's kind of a fool's errand to come up with a one-size-fits-all super LMS in the sky, but as long as you can come up with a clear set of rules for defining when stuff is passed between one side, okay, my responsibility ends and yours starts, then you can start to build these fractal ad hoc creations of things that can grow and expand and perform over time. And then kind of the correlated to that is all these modern learning opportunities and needs just don't model well as a single one-dimensional coarse-grained process. A lot of the stuff with andragogy and heutagogy and self-regulated learning, not everybody's going to excel in that. But the people who are going to excel in that, we need to be able to provide them an environment where they can. And we need to provide those environments so that they're on a level playing field. And last, is that Rome was not built in a day, and neither will be the TLA. Enterprise systems require a phased approach and a data federation strategy. You need to be able to build them in pieces and then connect them together later. So what the research was showing and what we're trying to do with the standards that we're participating in is give everybody Legos. And then they can put together the Legos themselves. And as long as the little round dots are all the same size and same spacing, it'll connect up. But whether or not you're going to get a Ferrari, or a space cruiser, that really depends on how you put them together.
Agreed. I think we all owe a shout out to a number of folks. And so with that, I would say I thank everybody for attending. If you made it this far, we really thank you for your time.
Yes, thank you.